So yeah, coming to this is code forces round division 2. The problem is build permutation, right? So here was giving us an array which was a zero based indexing array. You need to build a permutation such that ai plus I is a perfect square. So it is the just sum. So he see here when he was given 3, 0 plus 1 is 1, and 2 plus 1 plus 0 is 1, and 0 plus 1 is 1, and 2 plus 2 is equal to 4. You see, everything is a perfect square. So we need to build a permutation in this manner. So we'll just understand this. So let us understand with this test case. So what if he has given us 11? So you need to build an array for this indexes, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until 10. So you need to build an array until the index 10 such that ai plus I is a perfect square, right? So let us consider, first of all, consider the last element. Consider the element and just calculate the next perfect square which is greater than or equal to that index. Here when you compare this 10, the next greater than or equal to index which was a perfect square is 16, right? 16. Can I say this here for 10? The next greater than or equal to perfect square is 16. So you need to make it as a perfect square. You need to add something and make it as that perfect square. So what is this number? Can I say this as 6? So, and parallelly I'll assign this my 6 with 10, because see, 6 plus 10 is 16 and 10 plus 6 is 16. And when you take 9, 9 plus 7 is 16 and 7 plus 9 is 16. When you take 8, 8 plus 8 is 16. So coming to this, and this part is over, and coming to this, when you complete this part, and when you reach the next part, you'll again check the last element, which was 5. You'll check the next greater than or equal to perfect square, which was 9. So we'll assign the elements accordingly, that when then we'll say 5 with 4 and 4 with 5. And once it is completed, then you again check for 3. What is the next perfect square? That was 4. Can I say that? Yes. So once it is done, then we'll assign 1 with 3 and 3 with 1, and we'll assign 2 with 2, such that it will become my perfect square. And you'll assign 0 with 0. And this is the just brute force approach. Like, this is the main approach, not brute force, it's an optimized approach. So we'll just take another case. If there was 9, we'll build an index until 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. We need to build an index for this. Yeah. So you'll consider the last element and you'll just compare the next greater perfect square, which was again 16, here. Sorry, this was 9, right? Sorry, this was 9. So you'll consider 9. So until this index, you'll assign 8 with 1. So when you're saying 1, until this index, you need to consider a single perfect square, which was 9, and you'll assign the values according to that, which was 2 plus 7, 7 plus 2, 6 plus 3, 3 plus 6, 4 plus 5, and 5 plus 4. So these are the values until that perfect square. So when 0 is there, you'll assign 0 directly. So this was the main intuition over here. You'll take the last maximum element and you check the next greater perfect square, and you'll add that element, right? And you add, and whatever you're adding to that number until that index, you need to consider the same perfect square. You can't make, so here here my 3 is there. Even 3 plus 1 is also 4, which was also a perfect square. But if you assign that, the elements will be repeated, which won't be considered as a permutation. So in order to avoid that, you need to take the until that index whatever you're adding the element over here. So we'll take another example, like if I take 12, we need to build until 11th index 0 1 2 3 4 5 6 7 8 9 10 11. So until this index I need to build this. So these are my array of I. So you'll check this, you'll check, you'll take the 11 and you'll check what is the next greater than or equal to that perfect square, which was 16. So you take 16. What is the element that you need to add in order to get 16? 5, right? So until fifth index, I need to consider only 16 as my perfect square, because see, there are also, again I can say that there are also 5 plus 4 is also equal to 9, and 6 plus 3 is also equal to 9. Even those are my perfect squares. But if you do like that, there will be a repetition of elements which we don't want, right? So until this, I'll assign 5 with 11, and 10 with 6, and 6 with 10, 9 with 7, and 7 with 9, and 8 with 8. And once if the part is completed, and you'll go and see here, fourth, even you can take 9, but it is not the next greater. Even the next greater than or equal to that perfect square is just 4, right? 4. So what is the element that you need to add in order to get 4, which was 0? So until that index you need to consider only one perfect square. So here 0 plus 4 is 4, and 4 plus 0 is 4, and 3 plus 1 is 4, and 1 plus 3 is 4, and my 2 plus 2 is 4. So this was the actual intuition behind this. You just need to keep on repeating this process until you reach your destination. So coming, let us take like one more example. I'll take a smaller one, right? I'll take a perfect square, which was 10. So I need to build until this index 0 1 2 3 4 5 6 7 8 9. So you'll take the last element, and it is itself a perfect square, right? So what is the element that you need to, uh, the next greater perfect square which was greater than or equal to this index is 9. So we'll add 0, since it will become a perfect square. And whatever your element you're adding over here until that index, you need to consider the same perfect square and see, and you'll assign the values accordingly, that 1 with 8, and 8 with 1, and 7, and 6, and 3, and 4, and 5. So this is the actual permutation. So let's just quickly check this code. See, you are taking, first of all you're taking the integer input, and your vi means the vector integer. You can check out here, I'm declaring a vector, which was error, and I was decrementing one because since it was a zero based indexing, if he has given us 12, you need to design for 11, until 11th based indexing. So I was decrementing my n over there, and see, here I was checking my next grade. I was taking this element, and I was checking what is the next perfect square which was greater than or equal to this index. So I was checking this, and once if I get that, and I'll take this, and here what is my temp, here my temp variable is doing, since see, if my here my next, considering 9, here my next perfect square index is 9, right? And I'm removing that index which was 0, right? And this region until this index, it was indicating my temp. Okay, do you get that? See, if my n is 10, I need to build until the ninth index. And what is this what is the next greater perfect square which is greater than or equal to this index? And it is again 9, right? Which was again 9. So I'll get here 3 into 3, that was 9, minus 9, right? So my temp is equal to, indicating my 9 minus 9, which was equal to 0. So until that index, you need to consider this perfect square only. So it was indicate, so that's the purpose of my temporary over there. So I'm just keep on repeating this process. If my array of I is equal to 0, I'm assigning the values accordingly. See, once if my I is getting lesser than my temp, see here, we had already seen this before. Yeah, see here. Here 11 plus 5 is 16, right? So what is your temp? Your temp is 5 over here. So initially my temp will be 5, until this index will take only 16. So once if my index is lesser than 10, so we need to consider a new perfect square over here. So again I was calculating until the next perfect square which was appearing over here, which was equal to 4, right? I was decreasing and I was checking whether my index is greater than or equal to that perfect square or not, and I was just updating my temporary variable over there. And I'll just repeat this process until I get my desired output. So you can check. Sorry, my net was not there, and you can check out, even it got accepted for me. Yes.